Welcome back. We shall move on to the pricing and valuation of swaps, in particular interest rate swaps, for this lesson. Let's jump right in. Swaps are like forwards in many ways. Recall that forwards typically require no payment by either party at initiation, are custom instruments where the contracts are non-standard, are largely unregulated, and expose both parties to counterparty risk. All of these are true of swaps as well. In fact, swaps can be viewed as a series of forwards. Let's say these two parties want another exchange at another date on the same terms. They can initiate another forward contract with a different settlement date. Alternatively, they can enter into a single swap agreement where they exchange payments at the two settlement dates. A swap is defined as a contract whereby two parties agree to exchange a series of payments on periodic settlement dates over a certain time period. The contract ends on the expiry date, which is usually the date of the last payment to be made. At each settlement date, the two payments are netted so that only one payment is made. The party with a greater liability makes a payment to the other party. You may ask, what is the point of swaps? To illustrate, let us use an example of paying interest rates on a loan. The Green party may want to take a loan of $10 million, and for some reason he's offered a favourable fixed rate of 5%. However, Green prefers to pay a floating rate instead. The Red party also wants to take up a $10 million loan, and for some reason he's offered a more favourable floating rate. However, Red prefers to pay a fixed rate instead. So what both parties can do is to take up their respective favourable loans and enter into an interest rate swap with each other. This is a simple swap where one party makes fixed rate interest payments on a notional principal amount in return for floating rate payments from the other party. So in this case, the notional principal may be $10 million. At each settlement date, Red receives floating rate on the notional principal. Red is called the floating rate receiver. In return, Green receives fixed rate on the notional principal. Green is known as the fixed rate receiver. For reasons we'll explain later, we prefer to label them as receivers than payers. Nevertheless, you should know that Green is also the floating rate payer, while Red is the fixed rate payer. In the exam, you must be very clear which party is being referred to. Both parties can use what they receive to fulfill their respective debt obligation. So if you examine this carefully, Green is paying floating rate as he desires, while he is actually having a fixed rate loan. Conversely, Red is paying fixed rate while he is actually having a floating rate loan. What we've just described is a plain vanilla interest rate swap. The cash flows from the floating rate payer are obvious. It is simply based on the spot reference rate at each period. For example, if this is a 9-month swap where each settlement is 3 months apart, the appropriate reference rate may be the 90-day LIBOR. At initiation, only the next floating payment is known, as it is based on the current 90-day LIBOR rate. Based on 5% LIBOR, the first floating rate payment must be $125,000. The rest of the cash flows are unknown at initiation. The second cash flow will only be known at the next settlement date, which is fixed by the 90-day LIBOR rate on that day, and so on. So, given that future cash flows for the floating leg are unknown, how do we figure a fair fixed rate that both parties can agree on? We want this to be fair, such that like most derivatives, the value of the swap contract to both parties is 0 at initiation. One way is through replication. This plain vanilla interest rate swap can be replicated with a fixed coupon bond and a floating rate note. The fixed rate receiver is long the fixed coupon bond and short the floating rate bond. The value of the swap at any time is therefore the value of the fixed bond minus the value of the floating bond. For the floating rate receiver, he is long the floating rate bond and short the fixed rate bond. The value of the swap to him is therefore opposite of that of the fixed rate receiver. To keep things clean, we shall keep the discussion from the perspective of the fixed rate receiver, as the arguments for the opposite party are just a reflection of that. We prefer to use the term receiver because the fixed rate receiver is long on fixed rate, so the value of his position should correlate with the value of the fixed bond. For a start, let's be clear that we want V0 to be 0, so the par value of the two bonds must be equal. For simplicity, we just set them as 1. The principals cancel out at initiation and expiration, so there is no exchange of principal. The value of the fixed coupon bond is the sum of the present values of the fixed coupons plus the PV of the principal, which is 1. To calculate the PVs, we would need the corresponding LIBOR rates. We can also express them as discount factors to aid us in the mathematics, where the discount factor is calculated using the following formula. In the exam, you will likely be given the discount factors. Nevertheless, it is important for you to know how it is derived. Another very useful figure is the sum of discount factors. The sum of discount factors allow us to quickly calculate the PV of coupons. Since it is a fixed rate coupon, the sum of PV of coupons is simply the coupon amount times the sum of discount factors. The final discount factor is also useful as it allows us to quickly calculate the PV of principal. Since the principal is 1, the PV of principal is simply the final discount factor. Next, let's determine the value of the floating rate note. This is easy. At initiation and at each payment date, the value of the floating rate note resets to its par value, so the value is 1 at initiation. As mentioned earlier, since we want the value of the swap to be 0 at initiation, the value of the fixed coupon bond and the value of the floating rate note must be equal. Rearrange, we get this equation to calculate the coupon rate that makes the value of the swap 0 at initiation. So for this case, the coupon is 0.016. Since the par value is 1, this works out to an unannualized 1.6% coupon rate. Annualize it, we get a swap fixed rate of 6.4%. This is known as the price of the swap, which we denote as FS naught. Now that we've determined the no arbitrage swap fixed rate, let us briefly go back to calculate the fixed payments at each settlement date. On a notional principal of $10 million, Red is obligated to pay Green a fixed amount of $160,000 at each settlement date. Green has to pay Red an amount that corresponds with the 90-day LIBOR. So now that we've learned how to price a swap at initiation, how do we determine the value of the swap sometime later during the life of the swap? Like for forward contracts, we should first determine the price of the swap if a new swap is initiated with the same terms and expiry date. Again, let's use the replication technique to help us. For a start, note that the value of the floater is 1 only at initiation and payment dates. Since our formula is based on the assumption that the value of floater is 1, this is valid only at initiation and payment dates. For the purpose of the exam, we only need to know how to do this on payment dates. So let's say 90 days after initiation, the LIBOR rate has decreased to the following figures and respective discount factors. At this instance, there are only 2 settlements remaining, one in 90 days and another in 180 days. So we only need these 2 LIBOR rates and their respective discount factors. So based on the discount factors for these 2 cash flows, we solve for the coupon rate and get 1.24%. This works out to an annualized swap fixed rate of 4.96%. Now, if you look at it from the fixed rate receiver's perspective, he would only receive 4.96% fixed rate if he initiated a new contract today. However, based on his current contract initiated earlier, he will continue to receive a fixed rate of 6.4% for the remaining 2 payments. There is clearly value in the contract for him. The difference in amount is essentially the original rate minus the new rate, remembering to unannualize the rates, times the notional principal. The value to the fixed rate receiver is therefore the sum of the PV of these amounts. We can simplify it into this formula, which allows us to make use of the discount factor table. So at this point, the value to the fixed rate payer is $70,800. Like most derivatives, the value to the counterparty is the opposite amount. The value of the swap to the floating rate receiver is as such. Unlike forwards and futures, which clearly have a long and short party, the polarity of the value for swap parties is a little harder to comprehend. Instead of memorizing the formulas, it may be better to make arguments based on what situation brings value to the party, like what we've just done. And with that, we've learnt the pricing and valuation of interest rate swaps. Let's end with an exercise. Hammerhead Holdings recently issued a 1-year $5 million GBP fixed coupon bond. The company is confident that UK interest rates will fall during this period, so it enters into a £5 million 1-year pay floating receive fixed swap with a swap dealer with quarterly settlement. Given the following spot UK interest rates, determine a fair price or fixed rate for the swap. Pause the video now and work out your answer. And we're back. Let's first calculate the missing discount factor. Since the annualized 180-day rate is 1.8%, this works out to an unannualized rate of 0.9%. The discount factor is therefore 0.9911. The sum of the discount factors is 3.952. Let's first draw a timeline to help illustrate the problem. Hammerhead Holdings is the receive fixed, pay floating party in the swap. At initiation, no cash flows are exchanged as the principal of £5 million is equal. There are 4 settlements, 90 days apart, where the company receives fixed coupons and pays floating coupons. And at expiration, no exchange of principal as they are equal. As we've proven earlier, the unannualized fixed coupon rate can be determined using this formula. Plug in the discount rate, and we get 0.521%. Annualize it, we get 2.084%. This is the fixed rate of the swap determined at initiation, which is also the price of the swap. Next, on the second settlement date, the following spot interest rates are observed. What is the value of the swap to the dealer at this point? Pause the video now and work out your answer. And we're back. First, let's determine the price of a new swap contract on the second settlement date. There'll be 2 settlement dates left, one in 90 days and another in 180 days, so we'll just need these first 2 rates and their discount factors. The sum of these 2 discount factors is 1.9903. Do not use the given sum here, as it is the sum of the 4 discount factors. Using the discount factors, we can easily calculate the fixed coupon rate, which is 0.352%. The annual rate is therefore 1.408%. Take special note that we're asked to calculate the value to the dealer, who is the receive floating pay fixed party in this swap. The party benefits when the price of the swap increases, as it is paying a lower fixed rate based on the original contract. The value of the swap is therefore the sum of discount factors times the increase in price, remembering to unannualize the rates and multiply by the notional principal. Plug in the figures, we get minus £16,818. And that concludes this lesson on the pricing and valuation of interest rate swaps. There are a number of important formulas that you should remember from this lesson. First, the unannualized fixed coupon rate can be calculated using just the discount factors. Annualize the rate, you get the swap fixed rate, which is also the price of the swap. Second, the value of the swap on settlement dates are a function of the change in fixed rate over the original fixed rate. The fixed rate receiver benefits when fixed rate decreases, as he continues to receive the original rates. The fixed rate payer benefits when the fixed rate increases, as he continues to pay the original rates. See you at the next lesson, where we move on to equity swaps.